In this lesson, I want to find the nth term of a quadratic sequence using an alternative method. Instead of following a rule, I want to actually achieve what I want to use later. Let me have a sequence that has an nth term is an squared plus bn plus c. So I'm going backwards now. I want to produce the terms myself. So when n equals 1, the first term would be a1 squared plus b lots of 1 plus c. So 1 squared is 1 times a. That would be my first term. Let's find second and third term as well. When n equals 2, the second term, 2 squared, 2 squared, 4 times a, 4a, plus 2b, plus c. That is my second term. And when n equals 3, my third term would be a bracket open 3 squared plus b lots of 3 plus c, which is 9a plus 3b plus c. Now, let's use these terms. First term, a plus b plus c. Second term, 4a plus 2b plus c. And that would be my third term, 9a plus 3b plus c. So if this is my n, that would be my first term, second term, third term, etc. Now, let's go and find the first difference, as we did previously. First difference, second term minus the first term. Let's do that mentally. 4a, take over a. 2b, take over b, 1b. And c, take over c, nothing left. So that becomes the first number. Then let's go and find the difference between these two. 9a, take over 4a. That's 5a. 3b, take over 2b. Just 1b. And c, take over c. No c. Let's go for the second difference. Would be the difference of these two terms. 5a take over 3a. 2a, b take over b, no b. So I'm going to use these values to find the a, b, c of any quadratic nth term. Let's use the very example I used in the previous lesson. So we want to find the nth term of this sequence. The sequence being 10, 21, 38, 61, 90, etc. As before, we're giving these numbers in 1, 2, 3, 4, 5. Find the first difference. That's 11, 17, 23, 29. First difference. And then second difference. Six, 6, 6. So I will not now use the first method. All I want the first of the first difference, first number of the sequence, first number of first difference, and first number of the second difference. If you look what we call here, this value of 6, which is the first value of the second difference, is worth 2a. So this is 2a. 11 must represent 3a plus b. And 10 must represent a plus b plus c. In this case, we can find the values of a, b, and c starting from this end. 2a equals 6. Therefore, a equals 3. 3a plus b equals 11. But a is 3. So 3 lots of 3 plus b equals 11. 9 plus b equals 11. Therefore, b equals 2. Then I'm going to the fact that a plus b plus c equals 10. I know the value of a and b, replace. 3 plus 2 plus c equals 10. 5 plus c equals 10. Therefore, c equals 5. Now I'm going to replace the an squared plus bn plus c, which is the general nth term, with my values. So a would be 3n squared, b would be 2n, and c would be 5. This is exactly what I had using the first method. Another example using alternative method, and my numbers are this time -3, -1, 5, 15, etc. As before, give them the numbers n, 1, 2, 3, 4. Find the first difference. -1, -3, that's +2. 5 -1, and 15 -5. Finding the second difference. 6 take away 2, 10 take away 6. That's the second difference. If you remember, this is 2a, this is 3b plus a, and this number is a plus b plus c. The only problem with this method is you've got to memorize. This represents 2a, this represents 3b plus a, and this one represents a plus b plus c. If you think you can't remember these, then you have to do the first method. if your memory is good and you can remember the order of these, then use this method. So 2a equals 4. A equals 2. 3b plus a equals 2. Now if I replace a with 2, I was just talking about memorizing these terms. I made a mistake myself here. Instead of 3a plus b, I put 3b plus a. I just realized. So that 3a plus b. And here, 3a plus b equals 2. But a is 2. 3 lots of 2 plus b equals 2. Therefore, b equals 2 minus 6. Then going to the last clue, that a plus b plus c equals minus 3. A plus b plus c equals minus 3. Now let's replace. A is 2, b is minus 4, plus c. Here we have minus 2, therefore c equals minus 1. Therefore the nth term which is a n squared, therefore 2 a squared, n squared, minus bn, plus bn, which is minus 4n, and c, which is minus 1. I just replace a, b, and c in the general formula for nth term, which is a n squared plus bn plus c. That is my a, that's my b, and that's my c. That concludes our lesson on quadratic nth term of a sequence using both methods. One by achieving every step. Second one was actually remembering these numbers represent 2a, 3a plus b, and a plus b plus c. I hope you've enjoyed your lesson. My aim is to make your maths lessons as enjoyable as possible. Until next lesson, bye.